All right, let's take a look at the bulk of our logic lessons. And these are going to be our conditional statements. So like I said, our logic is basically what math is. It's drawing conclusions and then making conjectures about them. And we write those in conditional statements. We write them as if, then statements. Okay, so basically we're noticing a pattern. So if ABC happens, then XYZ happens. Okay, and there's two parts of our statement. The part that follows the if, and then the part that follows the then. So if ABC happens, and then if then XYZ happens. And we call those our hypothesis and our conclusion. So our hypothesis is what follows the if, and we call that the P part. And the conclusion is what follows the then part. And we call that the Q. So we're going to be using P's and Q's. There we go. Okay, so our example. Here's a conditional statement. If it is Saturday, then there is no school. So let's look at that. I should change colors, huh? Okay, so let's find the hypothesis and our conclusion out of this statement. Our hypothesis follows the if. So everything after the if. That is our P. That is our hypothesis. So it is Saturday. So it's just whatever follows the if until you get to the then. Then what's our conclusion? Whatever is after then. So this is the Q part. So there is no school. Okay? And that's it. Conditional statement, you got a hypothesis and a conclusion. What follows the if, what follows the then. Now we have some other statements we can make based upon our conditional statement. We can make a converse statement, an inverse statement, and a contrapositive statement. And they're all coming from our conditional statement. So our converse statement is formed by switching the hypothesis and the conclusion. So let me back up. Back up 1 second. Okay, so for our conditional statement, we have this symbol. Because if P, then Q. So we're going from P to Q. So we do a P arrow to Q. Okay, so our converse, we're switching our P's and our Q's. So then it's going to be Q goes to P. Okay, so our conditional statement. If it is Saturday, this is our original P, right? Our original conditional statement. This is going to happen at least once during my videos, doesn't it? And then there is no Saturday, that's our Q. So for our converse, we are just switching these two phrases. So our new statement becomes if there is no school, then it is Saturday. So you're just swapping the phrases for what comes after what. So now you can see that my Q is here. and my P is here. I'm trying to keep consistent colors and it's just not working. All right, that's it. We're just swapping them. The inverse, we're going to be adding something. The inverse is formed by negating, which means doing the opposite of both our hypothesis and our conclusion. So this time we're going to leave them right where they were on our conditional statement, but we're going to negate them. So if it's a positive, we're going to make it a negative. If it's a negative, we're going to make it a positive. Let me show you what that looks like. So here's our hypothesis, our P, here's our conclusion, our Q. So we're going to negate these. So if, right now it is Saturday. So if it is not Saturday, then there is school. See how I dropped the no? Because before there is no school, it's a negative statement. We're making it into a positive. We're negating it. We're doing the opposite of it. Okay? So the little symbols for this one are going to be, let me erase this P. This little squirrely line, P, goes to the squirrely line of Q. And what that little squirrely line means is negate. Okay? So, down here, our contrapositive is formed by switching and negating both our hypothesis and conclusion. So this time, we're going to switch them like our converse, and we're going to negate them like our inverse. Okay? So quickly, let me show you the symbol, negating, switching. So now it's if not Q. Oh, I said Q, so I wrote Q. Then not P. So let's write our statement. So if there is school, then it is not Saturday. Okay. Those are all of our statements that we're going to be looking at, writing, identifying. Let's look at an example. So a lot of times we're going to, I know for sure on the homework, we're going to be looking at a table. So we've got our conditional statement at top, and our symbol for our conditional statement is P goes to Q. Let's go ahead and just fill in the symbols for all of them. So our converse, we're switching those two. Our inverse, we're just negating them both. And contrapositive, we are negating and positive, and switching. Okay? So our example is going to be, if an animal is a beagle, then it is a dog. Okay, let's identify our hypothesis and our conclusion. So let's highlight our hypothesis in red. Anything that follows the if. An animal is a beagle. Okay? Conclusion. And everything after then. It is a dog. All right, let's write our converse. So we're switching the two. So if it is a dog, then it is a beagle. Let's write our inverse. So we're keeping the same order as the original. We're just doing the opposite. So if an animal is not a beagle, then it is not a dog. And finally, our contrapositive. We're negating both of them and switching both of them. So if it is not a dog, then it is not a beagle. All right. So now that we know how to write our statements, we know our symbols, we can fill out this table. This last column over here has truth values. So that's what you guys were doing for inductive reasoning, saying, hey, is this true or not? And giving counterexamples if it was not true. So let's look at each of these. If an animal is a beagle, then it is a dog. Is that true? If it's a beagle, it's got to be a dog? Yes. If it is a dog, then it has to be a beagle? That's not true. There's other kinds of dogs. So false. If an animal is not a beagle, then it is not a dog. Well, again, that's false because you could have, there's other kinds of dogs than beagles. If it is not a dog, then it's not a beagle. Well, that's true. If the animal is not a dog, there's no possibility that it's a beagle. So true. So we have true, false, false, true. So here's our general rule on our truth values. The conditional and the contrapositive are the same. And the converse and the inverse are the same. So is that true in our table? The conditional and contrapositive were both true. The converse and inverse were both false. So this is one option where the top and bottom ones are both true, middle are false, or the top and bottom are both false and the middle ones are both true. Or they are all the same. So all four of our statements could be true, or all four of our statements could be false. But you could not have true, false, true, true. Does that make sense? Let me know if it doesn't. There is practice on Canvas. Let me know if you have questions writing these statements.